Hello dear viewers, welcome to TV Math. In our today's session, I will be taking you through Senior 5 Midterm 2 Principal Mathematics Paper 1. This paper has been done by my students and even students from different schools. There are very many schools that trusted TV Math to set for them for Senior 5 and Senior 6. So I believe this paper might not be new to some of the students because you might have sat for the same paper. But for those that might not have seen this paper, please make sure you watch this video up to the end. Plus also those that have already attempted this paper, you need also to know what you were required and how you responded. Will it be matching with what we shall be giving out? So please watch up to the end. So at the moment, I believe the Senior 5s have already studied these topics. The first one is numerical concepts, talking about indices, logarithms, and surds. The second one is equations and inequalities, linear and simultaneous equations, quadratic equations, quadratic inequalities, polynomials. Then you should have studied coordinate geometry 1, where you are dealing with straight lines and partial fractions, linear factors, quadratic, repeated, and improper fractions. Then you should have studied trigonometry up to the end, that is up to the solution of triangles. That is for paper 1 specifically, so I will not talk about this. This is the topic in paper 2. This one, topic in paper 2, probability theory, that is paper 2. So again, I believe you have as well tackled on differentiation 1, dealing with gradient of a curve, gradient functions, curve sketching, and all that. Then you should have as well talked about integration 1. Integration 1, indefinite integral, definite applications, mean value of a function. And lastly, you should have looked at permutations and the combinations. Those are the topics I believe at the moment you should have studied. So these topics here have been divided into different constructs. For example, when you talk about numerical concepts, so numerical concepts are in a construct that we call algebra. So that is algebra. So when we are talking about this standard paper, this paper has been set looking at different constructs. So this is a standard paper, as I said. So this paper will be having this area here of constructs, because that is the part that you have already studied. So this is the part that we call algebra. So all these come in algebra. Equations and inequalities, this is algebra. Then coordinate geometry 1, this is in geometry. This is in the construct we call geometry. Then partial fractions, these come in a construct we call calculus. Then trigonometry, this is still geometry. This is still the area of geometry. Then next we shall talk about differentiation 1. This is also calculus. Differentiation 2, integration 1. Integration 1, this is still calculus. And the permutations and combinations, these are in algebra. So your mathematics paper will be divided into these 3, plus all other topics that you will be studying in the coming terms. You will be still studying the topics that fall under these 3 categories. That is calculus, geometry, and algebra. Then how is your paper classified? So the paper has got 3 constructs, as we have seen, but the item 1 will be a compulsory item, and this item comes from geometry. So at the moment, according to the paper that we shall be looking at, we expect you to now be having knowledge on coordinate geometry 1 and trigonometry. Those are the 2 topics that will be tested within this paper that you have so far looked at. Where is trigonometry? Here. So these are the 2 topics that you have so far seen. So that will be in geometry, and that number will be item number 1, which is compulsory. Then item number 2, item 2 and item 3 will be in the area that we shall be calling algebra. So this is how we shall be classifying these items. Then item 4 and item 5, item 4 and item 5 will be from calculus. So I think you still recall the areas that we have talked about: calculus, partial fractions. Then you talk about differentiation 1 and integration 1. And then algebra, you have permutations and combinations. You have partial, no, partial not. You have equations and inequalities, then numerical concepts. So this is for Senior 5, Term 2. At the moment, these are the topics you need now to be looking at. So, and I hope majority of the schools at the moment might have looked at all these, because we are coming close to the end of the Term 2. So you should have looked at all these topics, and that is where our paper will be based as well. So expect item 1 to be a compulsory item, which item is in geometry. And from geometry, as we have seen, you are expected to be responding to something to do with trigonometry and coordinate geometry 1. That is per paper 1. So that is the paper that we shall be looking at. So for those that are here for the first time, TV is my name, and I can be reached through this contact here. So I can write for you the contact. I can be reached via this contact. You can get me via this contact. So I can be reached via this contact, and TV is my simple name. For those that might be here for the first time, please consider subscribing to TV Math Hub. Subscribing is completely free of charge, but you will benefit in different ways, because whenever we upload a video, you will not miss out. And it is very important that you don't miss any video from TV Math Hub, because we are here specifically to make sure that you pass mathematics by all means. And by the way, we already have a group, a WhatsApp group. I will attach the link to the group in the description. So please join the group. It is almost getting full, and for those that are already there, they testify what they are getting. Please, very many papers have been shared on that platform, and others are still being shared. So if you are in Senior 5, you are in Senior 6, this is the right time to join that group. So without wasting time, let us look at this paper in details. So the instructions are, this paper will be consisting of two sections, A and B. Section A has one compulsory item. Section B has two parts, 1 and 2, and you are supposed to answer one item from each part. Additional items answered from each part will not be scored, and you are supposed to answer 3 examination items in all. So basically, that is the instructions to our paper, and from that, we shall come to our first item. As I said, this item will be from geometry, and at the moment, the topics that you have studied under that part, that is coordinate geometry 1 and trigonometry. So this item will be combining these topics here. We'll be combining these topics here. Okay, so let us look at the item. Let us look at the item. Now, as part of the Great Lakes Regional Connectivity Project, a consortium of civil engineers, urban planners, and energy consultants were tasked with designing a high-speed rail link and a smart grid energy network, connecting major hubs in Uganda, Rwanda, and Tanzania. During the surveying phase, road infrastructure planners identified key roads near the Kampala substation. A new road, that is Road 1, is being constructed and represented by this equation. It will intersect an existing Road 2, represented by this equation. A traffic light needs to be installed at the intersection point. Another planned road, Road 3, needs to be parallel to Road 1 and pass through at the point 4 and 1. A fourth road, which is Road 4, must be perpendicular to Road 2 and also pass through at the same point 4 and 1. The engineers need to determine the coordinates of the intersection point for the traffic light, the equations of the planned roads, and analyze the angle at the intersection. Finally, energy consultants were installing a series of solar tracking panels along the rail corridor. The panel's efficiency is maximized when the tilt angle theta, where theta is an angle from 0 to 360, satisfies the equilibrium condition given by this. So our task is, we need to assist the road infrastructure planners to, part 1, calculate the coordinates of the intersection point of Road 1 and Road 2, where the traffic light will be placed. 2, we need to determine the equations of the lines representing Road 3 and Road 4. Then part B, you need to calculate the acute angle between rod 1 and rod 2 at their intersection point. And lastly, we need to determine the values of θ at which the solar tracking panels should be positioned to achieve maximum efficiency. So that is basically the information that we are given. So now from the given information in the scenario, we need to first begin by looking at getting the coordinates of the intersection point of rod 1 and rod 2 where the traffic light will be placed. So we need to go back and check for the information that will lead us to that. So they are telling us this information that during the surveying phase, road infrastructure identified the key areas. We have a road 1 which is given by this. We have another road 2 which is given by this, and traffic light needs to be installed at the intersection point. So we need to get the intersection point between this road and this road. So we shall look at that first. So let us look at the required response. So part 1, we need to calculate the coordinates of the intersection point of road 1 and road 2. So we are given the two equations for the roads. Road 1 is given by this and road 2 is given by that. Now let us look at the required response. So we are given the two roads, road 1 and road 2, and we need to calculate the coordinates of the point of intersection of the two roads. So with these two equations, how best can we get the point of intersection? So we shall get the point of intersection by solving the two equations simultaneously. So I believe everyone knows how to solve these two equations simultaneously. We shall use the substitution method since we already have our y equaling to that, and y is 2x plus 3 and 3x plus 2y is equal to 12. So what we shall do is to substitute equation 1 into equation number 2. So when you do that, where there is y in this equation, substitute there 2x plus 3. So you will have 3x plus 2 times 2, that is 4. This times this, that is 6, equaling to 12. So the value of x will be equal to 6 out of 7. Now from there, obtain the value of y, because we know y is 2x plus 3. So substitute for y, and you'll be able to get 2 times 6 over 7 plus 3, which will give us 33 over 7. So basically, it means we shall be able to get the coordinate of intersection as 6 over 7 and 33 over 7. So that is what we shall have. Alternatively, you may basically consider here making y the subject. So when you make y the subject here, you'll be able to get y is equal to negative 3 over 2x plus 6. And since you already have that y is equal to this, and for this one you have already got y, you can as well equate the 2. When you equate the 2, then you'll be able to get the value of x, which will now give you the value of y. So basically, to award the full marks, here you must look at the correct substitution. Algebra is correct and the coordinates are correctly as stated. Please don't simply get x equaling to 6 over 7 and y equaling 33 over 7 and you stop there. That one will not give you the full mark. So that is what we said, some of the common errors. So those are some of the arithmetic mistakes during the expanding poorly. We also have incorrect substitutions and giving only the value of x, and yet they are asking for the coordinates. And another thing, when you give this answer, remember what you needed is the coordinates of the intersection point of road 1 and road 2, where the traffic light will be placed. So we can give the conclusion that the traffic light will be placed at the point. So we shall say the traffic light will be placed at the point. So remember, traffic lights need to be installed at the intersection point. So we can give the conclusion. So conclusion, the traffic light will be placed at the point which is 6 over 7 and 33 over 7. So this is the point of intersection, which is the point of intersection, between other two roads, which is the point of intersection of road 1 and road 2. So basically that is what was required per our item part 1. So part 2, they are saying determine the equations of the lines are representing road 3 and road 4. So when you look at that, road 3 and road 4, they are telling us that a traffic light, okay, another planned road, which is road 3, needs to be parallel to road 1, and you pass through the point which is this, it is to be parallel to road 1. And again, a fourth road must be perpendicular to road 2 and also pass through at the same point, which is 4 and 1. So with that given information, they have told us for part 2 we need to determine the equations of road 3 and road 4. So road 3 is parallel to road 1, and since we are given road 1 as given the equation of road 1 as y is equal to 2x plus 3, then from this we can pick the gradient. So the gradient is this one here, because this is of the form y is equal to mx plus c. So this is our gradient. So we get the gradient, but we know that for parallel lines they have the same gradient, which means that even road 3 will have gradient which is equal to 2, since road 1 has the gradient 2, because for parallel lines they have got equal gradient. So remember that this road 3 will now have the gradient which is 2, and it will pass it through the point which is 4 and 1. So using this point here, using this gradient here, we shall be able to get the equation of the line, which we can get because we know gradient is change in y over change in x. So use a general point on the line, that is y. So you are using the point for 1 and the xy. So the gradient is y minus, we can call that y1 over x minus x1. So the gradient is 2, which is equal to y minus 1 over x minus 4. We are using this line to be, this point to be x1 and the y1. So cross multiply, this will give us y minus 1 is equal to 2 into x minus 4, which means that y will be equal to 2x minus 8 plus 1. So you get y as a 2x minus 7. So that will be the value or the expression for the equation of the line. That is the line that we are talking about is road 3. So this will be the equation for road 3. You can as well give your answer in this form. That is equally acceptable. So that is basically for road 3. So we look at equation of road 4. Road 4 is perpendicular to road 2. So if the two are perpendicular, what do we need to do first? One, we need to get the gradient like the one we have obtained. So how do we get the gradient? Make y the subject here. So when you make y the subject, you will have y equal to negative 3 over 2 of x plus 6. So this will be y. So since this is in the form y is equal to mx plus c, so our m will be negative 3 divided by 2. So you'll be able to get negative 3 divided by 2. But for perpendicular lines, the product of their gradients is negative 1. So meaning that this will be like my gradient 1. So m1 times the gradient for the next one should be equal to negative 1. So negative 3 over 2 times m will be equal to negative 1. So m will be negative 2 over negative 3. So m becomes 2 divided by 3. So this will be the value of m. Now after getting m, we shall do like the one the way we have done here. M is equal to change in y over change in x. So when you do that, you should be able to get, this is change in y. So this one here is representing like gradient is equal to y minus y1 over x minus x1, meaning that y minus y1 is equally same as m into x minus x1. So that's why we have y minus 4. Remember, it is passing through the point 4, 1. So y minus 4, y minus 1, not y minus 4, y minus 1 equaling to m, which is 2 by 3 into x minus 4. So simplify this and check if you'll be able to get that answer. So basically that is how we obtain the equations for the roads, that is road 3 and the road 4. So you must give the conclusion. So give the conclusion. Give the conclusion, the equation for road 3 and road 2, road 3 and road 4. The equations for road 3 and road 4 are, so put those equations this and this respectively. So put those equations respectively. So those are the equations for road 3 and road 4 respectively. So put the equation for road 1 here, equation for road 2, and you look at that. So majorly to qualify to get all the marks, the candidate should clearly show how we obtain the gradients, how you use the point-slope equation, and you should be able to simplify. However, there are some common mistakes that you must need to always avoid. 1, using the same gradient for a perpendicular line. 2, forgetting the negative reciprocal, especially when you are looking at m1 times m2 is equal to -1, and some arithmetic errors while simplifying. So that is basically about part 2. That is about part 2, where we needed the equations of the line representing road 3 and road 4. So we shall talk about part B, calculate the acute angle between road 1 and road 2 at their point of intersection. So we need the acute angle. So how do we obtain that? So to calculate the acute angle between road 1 and road 2, we need to look at the gradients. So we shall do that by looking at the gradients. So from road 1, from road 1, which was given, so we had road 1. So road 1 is this. So its gradient, the gradient for this is m equaling 2 to 2. And the gradient for this we have seen when you try to make y the subject, to y is equal to -3x plus 12, and then y is -3 over 2x plus 6. And we shall be able to get the gradient as the -3 over 2. So we are interested in gradients first. So those are the ones that we shall use to obtain the angle. So we are saying the gradient for road 1 is 2. The gradient for road 2 is -3 over 2. So we shall use the formula that tan of theta is same as m2 minus m1 over 1 plus m1 m2. But here you can use even m1 minus m2, then divided by 1 plus m1 times m2. So it has no problem. So we are letting our m1 to be 2 and our m2 to be -3 over 2. So the naming here has no much impact. You can name this one to be m1 and you name this one to be your m2. So using m2 minus m1 over 1 plus m1 m2, you should be able to have, where there is m2 we shall put this m1, we shall put that. So simplify. So this will give us -7 over 2. You are dividing this by this is 1 plus this, and this will cancel. This is -3. So actually you will have -7 over 2 divided by -2, which is -7 over 2 times -1 over 2. So this will give you 7 over 4. So but magnitude of any number which is positive, it will remain positive. If it is still negative, it will remain positive as well. So get tan inverse of 7 over 4, and it will be able to give you 60.26. However, in case you have obtained a value like this, 119.74, this is an obtuse angle, but this angle will help us to obtain the acute angle. So the angle which is required here is an acute angle. So whether you get an angle which is greater, you must get its corresponding acute angle. So basically the candidates must state 60.26 degrees as the required angle, and the common error here is omitting the modulus. So when you omit the modulus, you might obtain an obtuse angle, and if you give the obtuse angle, then that answer will not be correct, because the question is specific, an acute angle. Then the calculator in radian mode, if the calculator is in radian mode, you might get a different angle compared to what is required. So you have to be careful there. You have to be so careful. So that is part B. We need the angle between road 1 and road 2. So please give the conclusion. Give the conclusion. The required angle. The required angle between road 1 and road 2. Between road 1 and road 2. Between road 1 and road 2 is 60.26 degrees. So this is the required angle. So next we shall look at the last part, determine the values of theta at which the solar tracking panels should be positioned to achieve maximum efficiency. So let us look at the part of the information that will help us there. This is the information given that finally energy consultants were installing a series of solar tracking panels along the rail corridor. The panel's efficiency is maximized when the angle theta, where theta is in this range, satisfies the equilibrium condition given by this. So we need to solve this to get these angles, to get the values of theta, which the solar tracking panels should be positioned to achieve the maximum efficiency. So looking at this, you are having a cos squared here, but this is sine. So you must create the relationship between cos and sine. But here, the one which is not squared will dictate on what you need to do with cos squared. So we shall use the first trig identity, which says that cos squared plus sine squared of theta gives us 1. So we need to put cos in terms of sine. So cos squared is equal to 1 minus sine squared of theta. So this is what we shall use. So where there is cos squared, we shall put this. So in this equation where there is cos squared, let's put this. So we shall have this as 2 into 1 minus sine squared plus 3 sine of theta minus 3 equaling to 0. So try to simplify and get negative 2 sine squared theta plus 3 sine of theta. This and this will give you negative 1 is equal to 0. So when you reach here, you have different ways on how you can do this one. Some people might let like P represent sine of theta. So when P represents sine of theta, it means you have this as 2P squared minus 3P plus 1, which is equal to 0. So here you can use the factor method, or you can use the quadratic formula. So to use the factor method, this is 2 times 1, which is 2, and this is negative 3. So the factors should be minus P minus 2P, because minus 1 and minus 2, when you multiply them, you get 2. When you add them, you get minus 3. So plus 1, which is equal to 0. So 2P into P minus 1. So you open the same bracket, P minus 1 plus negative. Okay, there's a mistake here. So this we should have it as so P is the common one here. So here we remain with 2P minus 1. Then open the same bracket, 2P minus 1. So put negative 1 out. So we shall have P minus 1 into 2P minus 1, which is equal to 0. So it means that either P will be equal to 1 or P will be equal to a half. But of course, P represents sine. So it means that sine of theta is 1 or sine of theta is a half. So that is basically what we shall have. So we shall begin by looking at sine of theta equaling to a half. For sine theta equaling to, let us begin with 1. So theta is sine inverse of 1, and the sine inverse of 1, when you come to quadrants, sine is positive here, negative 1 there. So any angle here, that is 90 degrees, and another angle would be when you come back here, which is 450 degrees, but that would be outside the given range, because the range is from 0 degrees less or equal to theta less or equal to 360 degrees. Next, we look at sine of theta equaling to a half. So theta is sine inverse of a half. Sine inverse of a half, that is same as 30 degrees. That is 30 degrees. So you need where sine is positive, that is the first quadrant, and the last. So we put 30 degrees here, we put 30 degrees here. So you will take these angles. This will be the first angle, 30 degrees, and this will be the second angle, 150 degrees. So in general, we shall have our theta as 30 degrees, 90 degrees, and 150 degrees. So this will be the angles. This will be the angles. So in general, we shall be able to say that the values of theta at which the solar tracking panels should be positioned to achieve the maximum efficiency are, that is 30 degrees, 90 degrees, and 150 degrees. Let us now talk about section B. Section B has got 2 parts, part 1 and part 2. In part 1, you are supposed to respond to only one item, but for this case, for us, we shall be looking at all the items. Part 1 of section B is from the construct that we call algebra. And under algebra, at the moment, I believe most of the schools should have covered these topics. That is permutations and combinations. That is equations and inequalities, then numerical concepts. So for our paper, we shall be looking at all those topics. Those 3 topics will be giving us the items under algebra. So let us look at item number 2. Item 2 says Dr. Sandra Nabakoza is in the final stages of establishing Ruwero Fruit Processors Limited, a modern fruit processing factory aimed at adding value to produce from local farmers in Ruwero district. While preparing for a crucial meeting with her financial and engineering advisors, she reviews key entries in her project planning diary to coordinate the physical and administrative designs of the facility. In one entry, the structural engineer noted that the rectangular processing floor area for the main unit must be exactly this square meters. He further indicated that the width of this floor is fixed at this is the width, to allow proper alignment of heavy machinery. Once the exact length is determined in this form, Sandra will use the integer parameter a to determine the absolute physical operating limit for the factory's daily processing capacity. Specifically, the volume of passion fruit concentrate produced daily, that is X in thousands of liters, must be strictly less than A units. This capacity limit A will later be used to interpret the daily break-even production levels. To understand the daily break-even levels, Sandra examines a polynomial P of X equaling to that, whose roots represent 3 distinct possible production levels in thousands of liters, at which total revenue equals total cost. Meanwhile, the administrative section of her diary details the board meeting arrangement. The factory has a board of directors consisting of local members and 3 representatives from a Kenyan agricultural cooperative. The total number of board members attending a critical meeting equals to the sum of the 3 break-even production levels from P of X equal to 0. The 3 Kenyan partners must sit together in a continuous block. And our task is, we need to help Dr. Sandra Nabakoza to 1, determine the exact length of the processing flow in that form. 2, to find the 3 distinct break-even production levels. State whether all the 3 levels fit within the physical operating limit of the processing flow. C, we need to calculate the number of possible circular seating arrangements for the meeting with the 3 Kenyan partners seated together in a continuous block. So that is basically the information that we are given, and we shall begin by looking at part A, where we need to determine the exact length of the processing flow in this form, where A and B are integers. So we have got this. In an entry, the structural engineer noted that the rectangular processing flow area for the main unit is, this is the area. We are given the area as that. We are given this as the width. And what we need is to obtain what we call the length. So since we are told that this is a rectangular and we know how to deal with area for a rectangle, we know that for the area of a rectangle, that is length times the width. So we are given the area as this, we are given the width as that. Now it means area will be same as length times the width, and our interest is to get what we call the length. Now from the information that we have, we shall be able to get the length by getting area divided by width. So we have our area as this, we have our width, so we shall get the area, which is this, we divide it by the width. And of course, when you simplify this, this will be same as 11 plus 5 root of 3 divided by 2 plus root of 3. Then you are dividing it by 2 plus root of 3. This will be same as 11 plus 5 root of 3 over 2 plus root of 3 times the reciprocal of this. When you look at that, this will give you 11 plus 5 root of 3 divided by 2 plus root of 3, which is squared. So from this, we shall be able to have that. Now, we need to first of all try to simplify this. So we try to simplify this. So this, when you have 2 plus root of 3 and this is squared, this is same as having 2 squared plus 2 times this times root of 3, then plus root of 3, which is squared. So that's why we have 4. This and this will be 4, then root 3, plus 3, because this will cancel with the square root. So you will have 4 plus 4 root of 3, then plus 3, and this will give you 7 plus 4 root of 3. So this will be when you simplify this. So it means we shall be able to get that one there. Now from there, we shall rationalize. We shall rationalize by multiplying by the conjugate of this. That is 7 minus 4 root of 3, and this 4. That is 11 plus 5 root 3 into 7 minus 4 root of 3. So from here, try to simplify. Try to simplify. So you simplify this one here by multiplying 11 with 7. That is 77. 77, 11 times this, that is minus 40. 4 root of 3. 5 root 3 times that will give us 35 root 3. Then 5 root 3 times this, we shall get 5 times 4, that is 20, and then root 3 with that will be 3. And the down one will be a difference of 2 squared, 7 squared, minus 4 root 3, which is squared. So this will be 77, and this with this will give us negative 9 root 3. This is 77 plus this will give us 60. So that is basically what we shall have. So we shall be able to get, okay, this should have been minus. So it is 77 minus 60. So that should be able to give us 77 minus 60, then minus 40. Okay, this is minus 44, that is minus 9. So basically we shall have 17 minus 9 root of 3. So that will be the length. So the length will be 17 minus 9 root of 3 meters. So it was it. So they are saying here further, okay. So let me see. So he further indicated that the width of this river, the width of this flow is fixed at this point here, 2 plus root of 3. So we wanted to get the value for the length in terms of a plus b root of 3. So generally, in terms of a plus b root 3, we shall be able to have our a as this value, which is 17, and our b as a negative 9. So basically, that is what we shall be able to get. So with this question here, you or the candidates must, one, make sure they simplify this, and that is by dividing by what we call the width. So this method is actually or equally acceptable. Says find the 3 distinct daily break-even production levels. State whether all 3 levels fit within the physical operating limit of the processing flow. So we are told that Sandra will use the integer parameter a to define the absolute physical operating limit for the factory's daily processing capacity. Specifically, the volume of passion fruits concentrate produced daily x must be strictly less than a units. This capacity limit A will later be used to interpret the daily break-even production levels. So to understand the daily break-even levels, Sandra examines this polynomial, whose roots represent 3 distinct possible production levels, at which total revenue equals total cost. Meanwhile, the administrative section of her daily details the board meeting arrangement. Now they are telling us that the total number of board members, okay, equal to the sum of break-even production levels from P of X equaling to 0. So we shall be able to get those break-even levels by equating P of X to 0. So part B, we need to find the 3 distinct daily break-even production levels, and that means that we shall be using P of X to get those break-even levels. So what we shall do is we need to simplify this expression. So we need to first of all get the value of x, which will satisfy this given expression. So you can easily do that by using possible rational roots. So the possible rational roots are the factors of 6. So we have 1, 2, 3, and 6. So can use plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So those are the possible roots. So you use those to determine one of them. So if you get one, you can use it now to obtain the others. So what we can do is we shall first use for x equaling to 1. So if x is equal to 1, what will be p of 1? You are substituting in this expression. So p of 1 is same as substituting where x is by 1. So this will be like that. So possibly this will be able to give us 1 minus 6 plus 11 minus 6. So this will be negative 5 plus 11, that is positive 6 minus 6, that will be 0. So p of 1 is equal to 0. So if we are able to use x equaling to 1 to get p of 1 equaling to 0, then it means x minus 1 is a factor. So we are saying x equaling to 1 satisfies this equation, and for that case it means x minus 1 is a factor. So if x minus 1 is a factor, you will use x minus 1 to get other values of x which satisfies this. So we shall use x minus 1 here. Here we have x to the power 3 minus 6x squared plus 11x minus 6. We shall use the wrong division method to obtain a simplified expression. So if we need x to the power 3 and this is x, here we shall use x squared. So x squared times x is x to the power 3 minus x squared. So you need to subtract here. This will be 0 minus 6x squared minus x squared. So you're having minus 6x squared minus x squared. So this will give us minus 5x squared. So we shall add there 11x minus 6. So next we need minus 5x squared. So this is x, so we shall put minus 5x. So this will be minus 5x squared. Multiply it here, becomes minus, that is plus 5x squared. So this is plus 5x. Okay, so plus 5x. So again subtract. So this will give us 0. This will be 6x minus 6. So here you shall add there 6 here, such that this will give us 6x minus 6. So when you subtract, this should be able to give you a 0. So what does this one mean? So using wrong division, we shall be able to get x squared minus 5x plus 6 with remainder 0. So it means we shall be having our polynomial p of x as x minus 1 into x squared minus 5x plus 6. So this means that this can now be easily simplified because we know how now to deal with the quadratic equation. So simplify this. Simplify x squared minus 5x plus 6. So get the two factors of 6 that you can add together to give you a negative 5, and when you multiply you will get a 6. So those will be negative 3 and negative 2. So it means x squared minus 3x minus 2x plus 6. So we want to simplify this. So this will be equal to x into x minus 3, then open in the same bracket x minus 3, then put here minus 2. So this will give us x minus 2 into x minus 3. So our p of x will generally be x minus 1 into x minus 2 into x minus 3. So the break-even points, that is where p of x is equal to 0. So when you have x minus 1, this will give you 0 when x is equal to 1. In other words, you are looking at the x minus 1 into x minus 2 into x minus 3 equaling to 0 at break-even point. This will be equal to 0. P of x at the break-even point, p of x will be equal to 0, which means this is equal to 0. And for that case, x minus 1 will be equal to 0, x minus 2 will be equal to 0, and x minus 3 will be equal to 0. So that is what we shall have, meaning that x is equal to 1, x is equal to 2, and x is equal to 3. So these will be at the break-even points. So remember, the condition, the operating condition is that this a that we obtained here should be used to interpret the daily break-even production levels, whereby this value a should be these values of x should be less than the value of a. So we need to interpret that. So remember, from part A we obtained our a as 17, and the operating condition states that x must be less than 17. And we can easily see for the values of x we have obtained, x equaling to 1, x equaling to 2, and x equaling to 3, we can easily say that since 1 is less than 17, 2 is less than 17, and 3 is less than 17, then we shall be able to conclude that all the three break-even production levels satisfy the operating limit. So that will be the conclusion. So generally we are saying all three break-even production levels lie within the physical operating limit, because the operating limit is 17 and those values must be less than 17. So that is what we shall have. So there are some common errors that you need to avoid. For example, missing one of the roots. There are some of the arithmetic mistakes that you make while you are trying to use the wrong division, and also forgetting to interpret the inequality that the values of x should be less than 17. So that would be the required answer, and that will help us, that will be the response to part B. So we shall look at now the response to part C, where they are saying we need to calculate the number of possible circular seating arrangements for the meeting within the three Kenyan partners sitting together in a continuous block. So we are told that meanwhile the administrative section of her diary details the board meeting arrangement. The factory has a board of directors consisting of local members and three representatives from a Kenyan agricultural cooperative. The total number of board members attending a critical meeting equals to the sum of the three break-even production levels. So we are told those who are attending the meeting is equal to the three break-even production levels. And remember, we had 1, 2, and 3. So when we add these together, we get 6. And this 6 here will be the total number of those that will be attending the meeting. However, the three Kenyan partners must sit together in a continuous block. So we need to calculate the number of possible circular seating arrangements for the meeting with the three Kenyan partners sitting together in a continuous block. Let's look at how we can deal with that. So one, we need to determine the total number of board members. The question states that the total number attending equals to the sum of the roots, and the roots we have 1, 2, and 3. So which means that there will be 6 board members altogether, and among them we have 3 Kenyan representatives who must sit together. Now, we shall first of all treat the 3 Kenyan representatives as one block, because they are sitting together in a continuous way. So for this case, we shall treat the 3 Kenyan representatives as one block. So you will have, they are sitting on a circular table, for example. So you will have 1, 2, 3. These are the non-Kenyans, but we have the Kenyans. They will be seated together. So if they are seated together, we shall treat them as one block. So in total, you will have 4 members. So you will have 4. That is now a table of 4 members with these ones sitting together. Now, the block together with the remaining 3 local members will give us 4 members that are around a circle. So we know for circular arrangements, if you are dealing with any objects that will be arranged on a circular table, then the total number of arrangements is n minus 1 factorial. Likewise, if we have 4 on a circular table, then the total number of circular arrangements will be 4 minus 1 factorial, which is the same as 3 factorial, and this will give us 6. Now, we have got 6 as the total number of circular arrangements. Now, remember the 3 Kenyans are seated together. So, internally, also for them, they can be arranged in 3 factorial ways. Now, we need to arrange the Kenyan representatives within the block. So within their block that we had treated as one, so the 3 representatives can as well be arranged in any factorial ways. So since they are 3, it will be 3 factorial, and that will be 6 ways. Now, to get the total number of arrangements, we shall get the 6 that we obtained here, then we multiply by the 6 that we have here, and that will be 36 factorial. It will be 36 arrangements. So in total, we shall have 36 possible circular arrangements. So that will bring us to the end of our item number 2. So with that, let us now look at how best we can answer or respond to item number 3. Let us now look at item 3. Item 3 is also an item under the construct which is called algebra. So for the topics that we have seen in algebra, as far as Senior 5 is concerned, and that is up to term 2, then we should be in position to answer this item as well. It says a coffee growers cooperative is evaluating the possibility of installing an automated packaging facility to meet rising export demand. Analysis of earlier production data indicates that when no coffee is packaged at the center records a weekly loss of 80 million shillings because of fixed operating expenses. Records further show that processing 400 bags of coffee yields a weekly profit of 48 million shillings, while processing 2,000 bags also results in a weekly profit of 48 million shillings. Management assumes that the weekly profit depends quadratically on the number of hundreds of bags processed and intends to formulate an appropriate mathematical model before investing in the new facility. Approval for the packaging facility will only be granted if the maximum possible weekly profit exceeds 160 million shillings and if the operating interval is capable of generating a weekly profit of at least 144 million shillings is considered satisfactory. Should either of these requirements fail to be achieved, the cooperative will defer the investment and continue operating its current packaging arrangement. Meanwhile, the cooperative has received a damaged shipment record involving 3 packaging components: large sacks, medium sacks, and sealing rolls. Due to an error in the supplier's electronic transmission system, the exact quantities delivered cannot be identified directly. The available information indicates that a total of 240 items was supplied. Each large sack occupies 4 storage units, each medium sack occupies 3, and each sealing roll occupies 2 storage units, giving a combined storage requirement of 760 units. During the quality assessment, every large sack requires 3 inspections. Each medium sack requires 2 inspections, and each sealing roll required 5 inspections, resulting in 640 inspections altogether. Payments to the supplier will only be authorized if the recovered quantities satisfy all the recorded delivery conditions. In addition, the export division requires at least 60 large sacks and at least 80 sealing rolls to meet existing international orders. Otherwise, an urgent supplementary order must be placed immediately. So our task is you need to use appropriate mathematical arguments. 1. To analyze the production and delivery information to determine the profit function, the attainable profit levels, and the unknown quantities of packaging materials. 2. We need to evaluate whether the proposed packaging facility and the available stock satisfies the cooperative's operational requirements. And C. We need to recommend with justification the investment and procurement actions that management should undertake. So that is the scenario we are given, and we shall see how best we can respond to this. We shall begin by looking at the first part. We need to analyze the production and delivery information to determine the profit function, the attainable profit levels, and the unknown quantities of packaging materials. We shall do that by looking at this information. So this is the information that will help us in getting that. So we are told that analysis of area production data indicates that when no coffee is packaged, the center records this loss because of fixed operating expenses. Records further show that when you process 400 bags of coffee, you obtain a profit of this, while when you process this, you obtain a profit of this. Now, management assumes that the weekly profit depends quadratically, this is very important, quadratically, on the number of hundreds of bags processed, and intends to formulate an appropriate mathematical model before investing in the new facility. Okay, so that is the information that we need to first use to get the to get the profit function. Now, let us look at the required response. So we shall let x to denote the number of hundreds of bags of coffee processed, and p of x to be the weekly profit function that will be in million shillings. Let us talk about the analysis of production and delivery records. So the profit model, they are telling us that we have that the weekly profit depends quadratically. When we talk about a quadratic function, this is the function of this nature, ax squared plus bx plus c. Now this is a quadratic function. A linear function is of the form ax plus b. A cubic function is of the form ax to the power 3 plus bx squared plus cx plus d. So when they talk about a cubic function, you relate with that, a linear function and a quadratic function. So since our profit function is assumed to be quadratic, so it means p of x will be equal to ax squared plus bx plus c. And remember, our x is representing as representing the number of hundreds of bags of coffee processed, and P of X is in million shillings. Now, from the given information, we are told that when no coffee is packaged, the loss is 80 millions. What does that one mean? It means our X will be equal to 0. And when X is equal to 0, P of 0 is negative 80. So when you look at this, what will be P of 0? It will be A into 0 squared plus B into 0, then plus C. Now, this is a loss. Remember, we are talking about profit, but when we talk about a loss, then it means that is negative of 80, which is equal to C. So C is negative 80. Now, we have obtained C as a negative 80. Next, they are telling us that when 400 bags of coffee are processed, then we get a profit of 48 millions. So it means when 400 bags are processed, our X will be 4, because our X is representing hundreds of bags. So our X will be 4, and P of 4 will be 48. Remember, our P of X is now AX squared plus BX plus C, and the C is minus 80. So it means when we talk about P of 4, we are looking at A into 4 power 2 plus B into 4 minus 80. So P of 4 is 48. So 48 is equal to 16A plus 4B minus 80. So which means that 16A plus 4B minus 80 is equal to 48. So when you take this one to the other side, should be able to get 4A, should be able to get 16A plus 4B is equal to 128. But this can be simplified as 4A plus B is equal to 32. That is when you divide by 4 through. So when you divide by 4, this will be 4A, this will be B, and this will be 32. So that will be 4A plus B equaling to 32. We shall call that equation number 1. When 2,000 bags are processed, what will be the profit? The profit will still be 48 millions. So when 2,000 bags are processed, it means our X will be 20, because X is representing hundreds of bags. So that will be 20. That will be the value of X. And P of 20 is still 48. So from our expression, which is this, when X is 20, P of 20 will be equal to A into 20 squared plus B into 20 minus 80. So which means that 400 of A plus 20B minus 80 will be equal to P of 20, which is 48. So that's why we shall have 400A plus 20B minus 80 is equal to 48, and you can bring this one, you'll get this equation. So when you divide through by 20, you should be able to get 2A plus B is equal to 6.4. So that is equation 1, and this is equation number 2. So solve the two equations simultaneously. One, we shall get equation 2, which is 20A plus B equaling to 6.4. We subtract 4A plus B equaling to 32. So when you do that, this will be able to give us the value of A as negative 1.6, because this will be 16A. This and this will cancel out. This will be negative 25.6. So the value of A will be negative 1.6. After getting the value of A, you can go on and get the value of B, and you should be able to confirm that the value of B is that. So generally, the P of X will be equal to negative 1.6x squared plus 38.4x minus 80. So this will be the profit function. So we have got the profit function. So the profit function is P of X equaling to that, or which you can write as this. So next we are told, so let us see, determine the profit function. We have obtained that. Then next are the attainable profit levels. So they are saying approval for the packaging facility will only be granted if the maximum possible weekly profit exceeds this. So we need to get the maximum weekly profit. And how do we get that? We shall obtain that by using the completing a square method, where we can easily get the maximum. So this is what we are having, and since we already have this, so what we shall do, we shall factorize out negative 16. So when you put out negative 16, this is same as negative 1.6. It is same as having negative 1.6 x squared plus 38.4x then minus 80. So I want us to deal with this alone. So when you place this one out, it is same as dividing it here and here, such that when you open the brackets, you will remain with the same expression. So that's why we shall have this, and this will be x squared minus 24x, then minus 80. So that is what we shall have here. So we have factored out the coefficient of x squared because we want to use the completing squares. And as you know, to use completing squares, the coefficient of x squared must be only 1. Okay, next. So let us look at the next. We need to use completing squares here. So we are having negative 1.6 into x squared minus 24x, then minus 80. So we are saying to use completing squares, look at the coefficient of this. So the coefficient of x is negative 24. So what you do, look at the coefficient, which is 24, divide it by 2. After dividing it by 2, you can even go with, you can take even the what, the minus, it is still okay. Then square it. When you square it, so when you divide this, you will get, okay, we can maintain the minus there. When you divide this, you will get negative 12. So this will be same as having negative 1.6 into x squared minus 24x. What you do, add that one there, add negative 12 squared there, then also subtract it. Add it and subtract it. You are generally creating a 0, then minus 80. So this will be negative 1.6 into. So when you look at this and this, this will be a perfect square, which will be x minus 12. And this is a squared. X minus 12, which is squared. Then minus, this will be 144 and minus 80. So that is what we shall have. Now this will be negative 1.16 into, so we have this, we have that. So this should be x minus 12 squared minus 144 minus 80. I want us now to open this bracket. When you open the bracket, it is negative 1.6 into x minus 12, which is squared. And then this multiplies with this, and this will give us plus 230.4, and then minus 80. So that will mean that we shall have our p of x as negative 1.6 into x minus 12 squared plus 150.4. So what does this one mean? This one means that since this coefficient here of this expression is, so we are saying since negative 1.6 is less than 0, then it means this function will give us a maximum value, and the maximum value will be taken as this. So the maximum will be 150.4. Of course, this p is in million shillings, so we shall have that million shillings. Then the maximum value p max occurs when this one is equal to 0, and that will be x equaling to 12, meaning that x equaling to 12 will give us the maximum profit. So that's why we are having that. So the maximum profit will be this, and it occurs when the production is 1, 2, that is 12 hundreds of bags. Now they were telling us that approval for the packaging facility will only be granted if the maximum possible weekly profit exceeds this, as we can see from the feasible profit levels that we must have the profit exceeding 160 million. So we shall talk about that when we are giving the general conclusion. But basically, we have seen this is the maximum profit, though this profit is less than 160 millions. It's less than the 160 million shillings. Okay, so we look at the next. Next, they are telling us the operating interval capable of generating a weekly profit of at least. So we need the operating interval because we have seen x equaling to 12, that is 12 hundreds of bags will give the maximum profit. But we also need to see whether this x, which is the value that is giving us the maximum profit, will be within the range that will give us the weekly profit of at least 144 million shillings. So let us look at that. Feasible profit levels for at least 144 million shillings. It means that we are interested in knowing the values of x for which p of x is greater than or equal to 144. So we already had our p of x as this. We already had that. So which means p of x, where it is, we place this expression, is greater or equal to 144. Then you can take this one this side and you will get minus 224. So it means 1.6 x squared, negative 1.6 x squared plus this minus this is greater or equal to 0. So we can as well here divide through by negative. As you all recall, whenever you divide by a negative, the inequality changes. So we shall have 1.6 x squared minus this one plus that less than or equal to 0. When you divide through by 1.6, you should be able to get this expression. So simplify this. Simplify this. So this can be simplified because we need factors of 1/4, which we can add together to give us 24. So that will be minus 10 and minus 14. So x squared minus 10x minus 14x, then plus 140 should be less or equal to 0. So x into x minus 10, open the same bracket, x minus 10, this is less or equal to 0, and this is minus 14 here. So x minus 14 into x minus 10 is less or equal to 0. So that's why we have this. Now from this given point, we must get the range of x that satisfies this inequality. So what we do, we get the critical points. So we get critical points by equating this to 0. So it means x will be 14 and x will be 10. So equate this and get the critical points. So these are our critical points. Now, how will the critical points help us? We shall be determining the range. For 1, since you have x equaling to 10, you have x equaling to 14. So what we shall do here is we shall look at the different regions. One, so other than doing this, you can do it like this. So you look at the region which is less than x, that is x less than 10. You look at the region between 10 and 14, and you look at the region which is above 14. So these regions are these regions here. So for where we have this is x less than 10. This is the region between 10 and 14, and this one here is the x greater than 14. So that is how else you can represent them. So next we need to look at x minus 10 into x minus 14. We need to look at that, this one here. So remember, we need where this one is satisfied. So we are looking at this x minus 10 into x minus 14. So in this region, you can use x equaling to 0, as we have seen. When this is 0, you will get a negative. When this is 0, a negative, so this will give you a positive. When you look at this region here, you can use like x equaling to 12. So when x is equal to 12, substitute it here, see what you get. We are interested only in the sign. So this will be 12 minus 10, that is a positive, but 12 minus this will give us a negative. A negative times positive will give us a negative. Next, you can choose like x equaling to 20. So this will be positive, this will be positive, giving us a positive value. So that is basically what we shall have. So we can easily see the range that is required is for when we have less than or equal to 0. So as we can see, the region which will give us the expression where x minus 10 into x minus 14 is less than 0 will be 10 less than x less than 14. But where do we get a 0? Where do we get a 0? When x is 10, we get a 0 here. So 10 qualifies. That is, x equaling to 10 will give us a 0, because we need now when this is less or equal to 0. So we shall get a 0 when x is 10 and when x is 14. So we shall have 10 less or equal to x less or equal to 14. And for that case, it means the solution where the product is negative or 0 will be this. So for therefore, we can say that we shall have 1,000. We shall have 1,000 less or equal to the Baggs process, that is x less or equal to the 1,400. So this one here is now for the Baggs process. So when it is x, it is in hundreds of bags. So it should be 1,000, because this is now for hundreds of bags. This is now times 100. This is now times 100, and this is representing already times 100. So the Baggs process will be in this range. So that is basically for the part 1. So part 1, we needed to look at the profit function, the attainable profit levels, which we have got, then the unknown quantities. Okay, next we shall look at the unknown quantities of packaging materials. Now we want to look at part 2, where we are basically talking about the packaging materials. Now let us look at to answer that. Now we shall look at this information. So they are telling us that meanwhile the cooperative has received a damaged shipment record involving 3 packaging components: large sacks, medium sacks, and sealing rolls. Due to an error in the supplier's electronic transmission system, the exact quantities delivered cannot be identified directly. The available information indicates that a total of 240 items, a total of 240 items. Remember, these items include large sacks, medium sacks, and ceiling rolls, was supplied. Each large sack occupies 4 storage units, the medium one 3 storage units, and the ceiling rolls occupy 2 storage units, giving a combined storage requirement of this. During quality assessment, every large sack required 3 inspections, medium required 2 inspections, and each ceiling roll required 5 inspections, resulting into a total of 640 inspections altogether. Payment to the supplier will only be authorized if the recovered quantities satisfy all the recorded delivery conditions. So let us look at how best we can respond to that. So we are letting X to represent large sacks, Y to represent medium sacks, and Z to represent ceiling rolls. So we are told that altogether they were 240 items. So altogether it means we have large sacks plus medium sacks plus ceiling rolls, giving us a total of 240, and that will be our equation. We are calling it now equation number 3 because we have already used equation 1 and 2. So storage units, we shall call this one equation number 4. For storage units, they told us that each large sack occupies this, and remember we are having X, we are having X large sacks. So it means if each large sack occupies these units, then it means the total units that will be occupied by this by all the sacks will be 4 times X, and this one will be 3 times Y, 2 times Z, giving us a total of this. So that will be our equation number 4. So quality checks. For quality checks, inspections, this for large sack it requires 3 inspections. So in total we shall have 3 times X because they are X large sacks. Each medium sack required 2 inspections, so that is 2 times Y, and each ceiling roll required 5, that is 5 times Z, and in total we shall add them and equate to 640. So that will give us equation number 5. Having obtained these 3 equations, then you should be able to know how to solve these equations. So solving these equations using elimination method or substitution method, you can be in position to get the value of X, Y, and Z. So I hope everyone knows how to solve such equations. When we go through this, we shall first of all use equation number 1. We make Y the subject, and we shall substitute this equation into 4. So after making Y the subject here, substitute it into this equation, and you'll be able to remain with X minus Z. So which means that the value of X can be Z plus 40, and that will give us equation number 6. Next, you also substitute that same equation, that is for Y, also substitute. So we have made Y the subject here, and we shall substitute it into equation 4 and equation 5. So when you do that, it means you will be remaining with equations in terms of X and Z. So we already have our X here as Z plus 40. So when you do this as well, when you substitute that equation into equation 5, you'll be able to remain with X plus 3Z is equal to 160, but we already have X as Z plus 40. So when you substitute it and simplify, you should be able to get the value of Z at 30. But here you can use any method of your choice, so long as it will be able to give you this value. So in general, you shall be able to get X as 70, Y as 140, and Z as 30. So make sure you solve this following all the methods. Don't get the answer by simply pressing this on the calculator and you get the values of X, Y, and then you must show the method of getting these values. So having obtained the values for X, Y, and Z, so it means the reconstructed quantities are large sacks, you will need 70 of them, medium sacks you will need 140, and ceiling rolls you will need 30. So next we shall look at another part. So here we are able to answer part A. Analyze the production and delivery information to determine the profit function, the attainable profit levels, and the unknown quantities of packaging materials. Part B, evaluate whether the proposed packaging facility and the available stock satisfy the cooperative's operational requirements. Remember, the requirements are the export division requires at least 60 large sacks and at least 80 ceiling rolls. So we need 60 large sacks, at least that is more than or equal to 60, and at least 80 ceiling rolls, that is at least 80, that is 80 and above. So Let us look at the assessment of operational requirements. 1. For packaging facility, the approval requires 1. The maximum profit should exceed 160 million shillings. But for us, the maximum profit we got was 150.4, and we can easily see that that value is actually less than, this is the value, this value is actually less than 160 millions. So it means one of the requirements will not be satisfied. So that is not satisfied. Then the next one, profit of at least, this one should be attainable over an acceptable range, and we found this was at the range, but this is satisfied because we had got our x here, we had got our bags, the maximum as 12, that was x equaling to 12, and that is same as 1,200 bags in total. And we can see this is an attainable range because the bags are ranging between 1,000 to 1,400, and yet our maximum was x equaling to 12, which gives us 1,200 bags. Remember, x represents hundreds of bags. So it means the profit of at least this is attainable over an acceptable range. That is true. Then this condition will be satisfied. However, we are given the condition that both conditions, that is here, we were told that should either of these requirements fail to be achieved, the cooperative will defer the investment and continue operating its packaging arrangement. Should either of these requirements fail, we can see that one of the requirements is already not satisfied. So it means the management stated that both conditions must hold, but since the first one fails, then it means the packaging facility should not be approved. So that would be about the packaging facility. Then we talk about the available stock, whether they satisfy the cooperative's operational requirements. So here we are basically looking at part B. So next we look at this one here, the packaging stock requirements. So one, we are told one, to have at least 60 large sacks or at least 80 ceiling rolls. So those are the requirements. So packaging stock requirements, we are required to at least have 60. We are required to at least have 60 large sacks. So it means for that case, we look at what is available. We have seen that we got 70 large sacks, and what we need is at least 60. So that one is satisfied. Then the next one, medium sacks, that is not actually talked about. Then ceiling rolls, we got 30, but how many do we need? At least 80. So you can see this condition will not be met. So it means there will be a shortage of about 50 ceiling rolls. So for that case, it means an emergency order for 50 ceiling rolls is required to hit at least the 80, which is the value, because the ceiling rolls should be more than or equal to 80, but we only have 30. So there is a shortage of at least 50 ceiling rolls. So that means the emergency order must be, because they told us that the payment to the supplier will only be authorized if the recovered quantity satisfy all the recorded delivery conditions. In addition, the export division requires at least 80 large sacks, and to meet existing, otherwise an urgent supplementary order must be placed. So this is the supplementary order that should be placed. So basically we look at part C, recommend with justification the investment and procurement actions that management should undertake. So part C, the management recommendations that we shall give. The investment decisions, we have seen that the maximum attainable weekly profit is this, which is below the required. So there it means the cooperative should postpone investment in the automated packaging facility. We are getting that from here, because they said should either of these, then the cooperative will defer the investment and continue operating its current packaging arrangement. So the cooperative should postpone investment in the automated packaging facility, and the existing packaging system should continue to be used. Then for the procurement decision, we can see that the recovered stock quantities are these, and the export department requires at least 60, at least 80 ceiling rolls, which is not met. So it means the management should release payment to the supplier since the records are consistent, but also place an immediate order for 50 additional ceiling rolls to meet export obligations. So that will be all about our item number 3. So we shall be now going to item number 4, which will be in part 2. Let us now come to part 2. For part 2, as we have said, this part will be for the construct that we call calculus. So this is the construct that we shall be dealing with in part 2. And also in this part, you are required to attempt only one item. So calculus, per the syllabus at the moment, you should be in position to deal with partial fractions. You should be in position to deal with differentiation 1 and integration 1. So those are the parts we expect to have in this part here. Okay, so let us look at item 4. It says, during the construction of a major bridge across the Nile River, engineers monitored the height of the bridge deck above the water level. The height h meters of the deck at time t hours after the beginning of the tidal cycle is given by the equation. This is the height given. The power consumption P in kilowatts of the heavy cranes are used on site varies with operating time t hours according to the relation P of t, which is equal to this. The total cost is in millions of shillings of completing X% of the bridge superstructure follows the model C of X, which is equal to that. The structural efficiency E of X of a particular support cable of length X meters is given by this. What is the task? We are told to calculate the velocity and acceleration of the bridge deck when t is equal to 2 hours. B, determine the rate at which the power consumption is changing with respect to time when t is equal to 3 hours. And C, find the value of X for which the construction cost is minimum. Confirm the nature of this point and sketch the graph of C of X for 0 less or equal to X less or equal to 10, showing the turning point clearly. And lastly, you need to express the efficiency function E of X in partial fractions. So that is our item number 4. We shall look at the solution. So we are interested in calculating the velocity and acceleration of the bridge deck when t is equal to 2 hours. So we are given that engineers monitored the height of the bridge deck above the water level. The height h meters of the deck at time t hours after the beginning of the tidal cycle is given by this equation. So we need to obtain what we call the velocity. The velocity is the rate of change of displacement. So that is same as getting dh dt. So since we already have h as that, we can easily get dh dt by differentiating with respect to t h, and h is this one. So we are differentiating this. So when you differentiate this, you should be able to get 3t squared minus 18t plus 24. So giving us this. So you are differentiating, you are differentiating t to power 3 minus 9t squared plus 24t plus 15. So you are differentiating this with respect to t. And what do? Drop the power, reduce the power by 1. Minus drop the power, reduce the power by 1. Drop the power, so it becomes 24t to power 0, that is 1. Plus this will be 0. So generally we shall have 3t squared minus 18t plus 24. And that is the value we shall have. But we need at time t equaling to 2. So substitute where there is t, put there 2. So when you do that, v of 2 will be equal to 0. So that will be the velocity. So the velocity will be equal to 0. Then how do we get acceleration? So the acceleration is the derivative of velocity, because acceleration, that is the rate of change of velocity. So what was velocity? Velocity was 3t squared minus 18t plus 24. So that is what you will be differentiating. So generally you are getting acceleration at time t as the rate of change of v, but v is 3t squared minus 3t squared minus 18t minus 18t plus 24. So this will be same as 60 minus 18. Place there the value of t as 2, and you should be able to get negative 6 meters per hour squared. So basically that will be the acceleration and the velocity of the bridge deck when t is equal to 2 hours. Next, we need to determine the rate at which the power consumption is changing with respect to time when t is equal to 3. So we are given the power consumption as this, and we need to get the rate. So with the power consumption as that, so we need to get the rate of change of power consumption. So it means you are to differentiate this expression with respect to t. So what we shall do, we shall relate this to be u, we shall relate this to be v, and we shall apply the quotient rule. So the quotient rule is u is v du dt minus u dv dt over v squared. So we are saying it is same as v du dt minus u dv dt over v squared. So what you will do is you let your u to be this. So u is 2t squared plus 8t. So when you differentiate this, you get 4t plus 8. When you differentiate this, you get 1. Then substitute in this expression. So the p derivative of t will be same as v. What is your v? Your v is t plus 4. So your v is this. And then what is it? Du dt. Du dt is it? Your v is t plus 4. Then du dt is 4t plus 8, this one here. So that is what we are having here. And then next we shall have u. Your u is this one, 2t squared plus 8t. And then multiply by dv dt. dv dt is 1. So that's why n number times 1 remains that number. Divided by v squared, and that is what you get. So from here, you can simplify this. So first simplify this. That is 4t squared plus 8t plus 16t, that will give us 24t, and then plus 32 minus 2t squared minus 8t. So when you do that, you'll be able to get that. So from that, you can easily realize that this can be written as 2 into t squared plus 4t, 2 into t squared, this is plus 8t, and then plus 16 divided by t plus 4, which is actually squared. Actually, you can easily see that what you have here, t squared plus 8t plus 16, is actually t plus 4 to the power of 2. When you expand this, you get this. So you are dividing this by t plus 4, which is squared. So this and this will cancel, and you will be able to remain with 2. So it means at t equaling to 3, the power will remain 2 kilowatts per hour, because they are telling us that the power consumption P in kilowatts of the heavy cranes used on site varies with operating time t hours according to this relation. So it means P derivative of 3 will be 2, and that will be P dt, and it means you have answered the rate at which the power, so the power consumption is changing with respect to time at t equaling to 3 will be, you need to give that conclusion, will be 2 kilowatts per hour. Okay, so that will be the rate. So give that conclusion, and that should be the answer. So the rate at which the power consumption is changing with respect to time when t is equal to 3 is 2 kilowatts per hour, and that will be your answer. So make sure you give that conclusion. So always give the conclusion, the rate at which the power consumption is changing with respect, the rate at which the power consumption is changing with respect to time when t is equal to 3 hours is 2 kilowatts per hour, and that will be the answer. Part C, we need to look at find the value of x at which the construction cost is minimum. So we need to get they are saying the total cost C in millions of shillings is this. So we need to get the value of x for which the construction cost is minimum. So we have the construction cost equation as C of x, which is equal to this. So we need to get the minimum point, and to get the minimum point, you need to firstly differentiate this. So differentiate this equation. To differentiate, drop the power, it becomes 9 x to power 2 minus, drop this, reduce the power by 1, 54x plus 72. So you can pull out the 9, you remain with 9 into x squared minus 6x plus 8. So since we have x squared minus 6x plus 8, you can have this as x squared minus 4x minus 2x plus 8. You are looking for the factors of 8, which you can add together to give you negative 6. That is negative 4 and negative 2. So this will give us x into x minus 4, then minus 2 into x minus 4. So giving us x minus 2 into x minus 4. So that is what we shall be able to get. So that's why we have 9 into this. Now look at for the turning point. We know for turning point, c derivative of x will be equal to 0. So we shall have 9 into x minus 2 into x minus 4 equaling to 0, giving us x as 2 and x as 4. That is what we shall get. Now we need to test which one of these values of x will give us a minimum value. So we shall now use the second derivative test. So differentiate your first derivative. Remember, the first derivative was this one here. 9x squared is 9x squared minus 54x plus 72. So that is, now from here we shall now have c double derivative of x as, differentiate this, drop the power, it becomes 18, reduce the power by 1, it remains x to the power 1 minus 54. Now with that we have c double derivative. Now you will put these values, x equaling to 2. So this will be 18 times 2 minus 54, and this will give us negative 18, which value is less than 0. So it means x equaling to 2 gives minimum, gives maximum, because negative 18 is less than that, gives maximum turning point. So x equaling to 2 will give us a maximum point. Now we need to check the value of x that will give us that will make the cost to be minimum. So this will maximize the cost. Now for x equaling to 4, so c double derivative of 4 will be 18 times 4 minus 54, and this is 18, and this value is greater than 0. So this will give us a minimum cost. So from there we can easily now get the minimum cost, because we know the value of x that will give us a minimum cost. So how do you get that? Go back and substitute in the expression for c of x. So c of x was given as this. C of x is here. So you are substituting in this expression of 3x to the power 3 minus 27x squared plus 72x. You are substituting in this 3x cubed minus 27x squared, then plus 72x plus 120. So substitute for the value of x as the value of x as 4, and you'll be able to get c of 4 as 168. So that will be the minimum cost. So the value of x which will give the minimum cost, remember this cost is in millions of shillings. So it means the minimum cost will be 168 million shillings, and that will be the value. And this occurs when x is equal to 4. Remember, the x is x percent, because we are saying the total cost x in millions of shillings of completing x percent of the bridge follows this. So it means the minimum cost will be this, and this occurs when x is 4%. So from there we as well need to sketch the graph of c of x for this range here. So to sketch that, we have already got our turning points. We have already seen that this is a maximum point because we got x equaling to 2. We got x equaling to 2 to be the value of x that gives a maximum cost. And when you substitute it back, when you substitute x equaling to 2 into this equation, this one here, it means you have c of 2 as 2 to the power 3 minus 27, 2 squared plus 72 times 2 plus 120. So this will be c of 2, and when you simplify that, you should be able to get, so we shall be able to get 180. So we so far have this maximum point 2 and 180, minimum point 4 and 168. So we can as well attest for the endpoints, because we need to sketch from 0 less or equal to x less or equal to 10. So for c of 0, when you substitute it in this equation, you should be able to get 120, and when you substitute c of 10, you should be able to get 420. So there we shall be able to draw this curve here. So our curve will be for 0 it is at 120. For 0 it is at 120. We have this as a maximum. This is a maximum point. So this one here, the curve will be turning like this. Then this is a minimum point, so it will be turning and moving towards x equaling to 10. So that will be our sketch. That will be our sketch. So we shall have that as a sketch. That will be the sketch for the curve. Okay. So with that, we shall be able to obtain the sketch. We shall be able to obtain our sketch. Okay. Now from there, we shall now look at part next. So that is part D. Express the efficiency function e of x in partial fraction. So we are given e of x as this, and we need to put this in partial fractions. Okay. So that is basically what we shall be having now from what we are given. E of x is 4x squared plus 5x minus 6 divided by x minus 3 into x plus 2. So we can easily see that the numerator and denominator have got equal degree. So what we shall do is to first use the wrong division. Now we shall try to first of all simplify this. That is x minus 3 into x plus 2, and this will be x squared plus 2x minus 3x, that is minus x, then minus 6. So what we shall do first is to use the wrong division, and when you use wrong division, it means you will have 4x squared plus 5x minus 6. Then you will have this as x squared minus x minus 6. So you need to have 4x squared here, so we shall place 4, and this will be 4x squared minus 4x minus 24. So when you look at this, when you subtract, this will be 0, this will be 9x minus 6 minus 24, that is plus negative 6 plus 24, that is plus 18. So it means our quotient will be 4. So this expression of ex will be same as 4 plus the remainder is 9x plus 18. Then you are dividing it by x minus 3 into x plus 2. Now this will now become a proper fraction. Now with this, you know that we can easily deal with this one here by looking at what we call the denominator. So we have linear factors in the denominator, and as we can easily see, we shall have to first deal with this. So this is 9x plus 18 over x minus 3 into x plus 2. So what we shall do here is to have this as a over x minus 3, because these are linear factors, so it becomes a over x minus 3 plus b over x plus 2. So when you do that, you will have to multiply through by the denominator here. When you multiply it here, you multiply it on this, you multiply it on that. So you'll be able to get 9x plus 18, which is equal to a into x plus 2 plus b into x minus 3. We have multiplied by the LCM throughout. OS, get the LCM, then cancel the LCMs out, but you'll be able to get a into x plus 2 and b into x minus 3. We have got different ways of how we can get a and b. When you reach here 1, that you can first simplify this. 9x plus 18 is equal to ax plus 2a plus bx minus 3b. Then when you look at that, ax and bx, combine them together because they are coefficients of x. So you will have a and b into x. This and this, then you factorize out to the x. Then this and this are constants, have 1 brackets for them. So from here, a plus b, you will equate the coefficients of x. So when you equate the coefficients of x here, a 9 will be equal to a plus b. When you equate the coefficients of x to the power 0, those are constants, then 2a minus 3b will be equal to 18. So you have these two equations which you will solve together to get the value of a and the value of b. So the value of a will be a 9 and the value of b will be a 0. So that is one way. The next way you can do that, after reaching this step, 9x plus 18 is equal to a into x plus 2 plus b into x minus 3. So what you can do is you can say for x equaling 2, you want to eliminate this, so it means you put x equaling to negative 2. So this will be negative 18 plus 18 is equal to, when you put negative 2 here, this will be b into negative 5. But of course this is 0, which is equal to negative 5b, and your b will be equal to 0. Then to get a, you want to eliminate this b. You want to eliminate that b. So what we shall do for x equaling to 3, so this will be 27 plus 18. So 27 plus 18. So this will give us 45. So we shall have 45, which is equal to, we want to eliminate b, so this will be 0, this will be 3 plus 2, which will be 5a. So this implies that a will be equal to 9. So we have the value of a as 9. So having obtained the value of a as 9 and the value of b as 0, then you will go back and substitute them in this equation. So it means where we have a, it will be 9, and where we have b, it will be 0. So it means the whole of this will go away. We shall remain with 9 over x minus 3. Then you add it with 4. So it means we shall be able to get our e of x as 4 plus 9 over x minus 3. And this will be the required answer. So our ex in terms of partial fractions will be that. So basically, that is all about our item number 4. So generally here you need to accept an equivalent algebraically simplified form of p dash of t. So these are some of the guidelines for the examiners. In part C, the candidates may use either the second derivative test or a valid first derivative sign change test to classify the stationary points, because we know there are two different ways of how you can show the classification of the stationary points. You can use the second derivative test, or you can use the first derivative sign change, and you get the answer 2. Another one, you need to award for a credit for correctly sketched cubic graph showing the intercepts, the local maximum and local minimum, and increasing behavior for x greater than 4. So this one here, we have already looked at the sketch for that. We looked at the sketch for that, where basically for, of course, this is for x-intercept. For x-intercept, so this for x-intercept, y is 0, but of course you realize your curve in this region, it will not be cutting the y-axis. So for y-intercept, x is 0, and when x is 0, you realize that c of 0 will be 120. So that's why we have the starting point here. But at this given point here, we have this one here. This is the maximum point. This one here, it comes from here, and this is our minimum point. And beyond that is x greater than 4, the curve will be increasing. The curve will be increasing. So this is your curve for c of x. Which is equaling to 3, x to power 3 minus 27, x squared plus 72x plus 120. This is a sketch. You might not need to use these scales here, because this is supposed to be a sketch. So the most important points you should have is 0 and 120. You should have this as 2 and 180. So this is a sketch. So simply sketch this as z. So here you have your c of x. Here you have your x. So the most important points you need this one here. The most important points you need this one here, which is, let's check that. So you need this one here, which is 120. You need this one here, which is z. You need a point like 168. Then you need a point like 180. So such that you will have this point here. Then you will as well have the point corresponding to, so this is 2, then this is 4, and the next like that. So this is your point 0. Now that is what you are having. So next you will have 2 and 180. 2 and 180, which will be like that. Then you have 4 and 168, which will be around there. So it will come like this. When it reaches here, it turns from here, it reaches here, it turns, and it will be going like that. Because you can easily see, for example, for x tending to positive infinity, then what will happen to your curve? You realize that c of x will be increasing, because whichever value you put here for a positive value, the x to power 3 will be increasing, and this means that y will be tending to positive infinity as well. So that's why your curve is going there. So these are the most important points. You must have 2, 180, and then this point as 4 and 168, then this point as 0 and 120, and this will be your sketch for c of x equaling to, you put that. So that will be your sketch for c of x. Now we have seen that you need to award a full credit for a correctly sketched graph showing one this intercept, this maximum point, and this minimum point, and the increasing behavior for x greater than 4. So for that, you'll be able to get full marks. In part D, candidates who proceed directly to partial fractions without first simplifying or carrying out polynomial division should not receive full marks, since the fraction is improper. So the fraction was improper, and therefore you need to first deal with wrong division. So that is all about item number 4. Lastly, we shall look at item 5, which says an agricultural engineering team working on an irrigation scheme in the eastern region studied the behavior of water in a main distribution canal. The depth d of the water in the canal t hours after opening the gate is modeled by this equation. The flow rate q, that is cubic meters per second through the canal, follows the relation q of t, which is equal to that. The total maintenance cost, C, in thousands of shillings for x kilometers of the canal, is modeled by this. The performance ratio of the main pumping system is expressed as f of x, which is equal to that. So the task is find the rate of change of the water depth at t equaling to 1 after opening the gate. B, calculate the rate at which the flow rate is changing when t is equal to 2 hours. C, determine the turning points on the maintenance cost curve. State the nature of each turning point and sketch the graph of c of x, indicating the positions and nature of the turning points. Then next, we need to decompose the performance ratio function f of x into partial fractions. So this is an item from calculus as well. This is an item from calculus. And that will be our last item in part 2 of section B. We shall look at the required solution. So we are interested first in obtaining the rate of change of the water depth at t equaling to 1 hour after opening the gate. So we are given the depth d of water in the canal t hours after opening the is modeled by this. So let us look at the rate of change of water depth at t equaling to 1. So we are given d of t as this, but we can easily simplify this by multiplying this one inside, and that will be 5t to the power 3 minus 8t squared. And next we shall be differentiating this. So differentiate this with respect to time, and that's why we have dt of d. So this will be same as differentiating this, that is 15t squared minus 16t, and that is what we shall have. Then at t equaling to 1, then substitute at t equaling to 1. At t equaling to 1, this will be 15 into 1 minus 16, and that will be negative 1 meters per hour. So the negative sign indicates that the water depth is decreasing at a rate of 1 meter per hour after basically 1 hour. So that is about part A. Part B, they are saying calculate the rate at which the flow rate is changing when t is equal to 2 hours. The flow rate is given by q, which is this. So we need to obtain the rate of change of the flow rate. So given q of t as this, we need to differentiate this. So we shall as well be applying the quotient rule. So we call this one u, we call this one v. So what will be du dt? Du dt will be 3, dv dt will be differentiating t squared. When you differentiate this, you will get 2t. So apply the rule which says we shall be having a v du dt minus u dv dt divided by v squared. So the v is t squared plus 2, then du dt is 3 minus this is u, then dv dt, that is 2t. So this is u times dv dt, and this is what you have divided by v squared divided by t squared plus 2, and everything is squared. So try to simplify that, and you'll be able to get a 3t squared plus 6 minus, now here we are multiplying 2t here, that is 6t squared, and that is 10t, then we have minus there. So generally when you simplify, you should be able to get a minus 3t squared minus 10t plus 6, and at t equaling to 2 and at t equaling to 2 you should be able to substitute 2 and you should be able to get this value. So from this it means the flow rate is reducing at 0.722 meters cubed per second. Meters cubed per second, because q is in meters per second throughout, and we are determining the rate of change, and the rate of change, okay, t, okay, the t is in hours, so that's why we have this again per hour, because the t is in hours and this is in seconds. Or else you can now convert, you can get this one here again, you divide by the seconds which are in 1 hour if you don't want to include this. So it means the negative value shows that the flow rate is reducing at this per hour in t equaling to 2 hours, and that will be basically the answer. So from there we shall have obtained the rate at which the flow rate is changing when t is equal to 2 hours. So this is for t equaling 2 hours, and that's why we are putting here per hour. I mean the turning points. Determine the turning points on the maintenance cost curve. State the nature of each turning point and sketch the graph of C of x indicating the positions and the nature of the turning points. So looking at part C, which is saying determine the turning points on the maintenance cost curve, state the nature of each turning point and sketch this, indicating the positions and nature of the turning points. So we need to look at the solution to that. So we are given our C of x as this, and we need to find the stationary points. So we need to differentiate this with respect to x. So differentiate this expression with respect to x, and you'll be able to get 6x squared minus 48x. So drop the power, reduce the power by 1. So you'll be able to get that. So at turning point, dc dx will be equal to 0. So equate this to 0, and you'll be able to get x as 3 and x as 5. So from that, we need to look at the nature of the turning point. And as we have seen, we can use the second derivative test or the sign change test. So using the second derivative test, we shall differentiate this again. So when you differentiate this for the second time, you will be able to have this as 12x minus 48. 12x minus 48. So the 2c, the x squared, will be 12x minus 48. And from that we shall be able to get the second derivative, and we need to test x equaling to 3 and x equaling to 5. So for x equaling to 3, we shall be able to get negative 12, which means that this is less than 0. The second derivative is less than 0. If it is less than 0, then it means the point will be a maximum. So you can get the maximum point by getting the value of c of x at x equaling to 3. So we had our c of x as 2x to power 3 minus 24x squared plus 90x plus 200. So you are substituting for x equaling to 3. And when you do that, you'll be able to get 3 and 308. And this will be a maximum point. At x equaling to 5, when x is equal to 5, what shall we have when x is equal to 5? When x is equal to 5, then the second derivative will give us 12. The second derivative will give us 12. And after getting that, then you will go on and obtain the minimum point, and the minimum point will be 5 and 300. You will as well do like the way we have done for the maximum point. So we have 3 and 308 as the maximum, 5 and 300 as the minimum. So we have those values there. So we shall try to draw our curve, and this will be the nature of the curve. This is our maximum point. This is our minimum point. So it means it will be coming from a point where for x equaling to 0, if you put x equaling to 0, it will be 200. So it means at x equaling to 0, it will be 200. So you have like 200 there, and it means your curve is coming like that. But what we are interested in is the maximum and the minimum point, and where the curve is taking. So in general, if we want to draw this as well, you can simply, this is a sketch, so you can have your 0, and then 0, this is 200. So this is 0, then this is 200. We need a point 3, we need a point 5, and we need 3 with 308. So we have like 300 there, we have 308 there. So we can have that. This is a sketch. So we have 0 and 200. This is where it is intersecting the y-axis. So that is it at when x, when it is when the x is 0, so y will be this actually this is c of x. So this is like our y. So this is point, which is the intercept on the y-axis, and this one here, when we move, this one here is a maximum point. 308 is a maximum point. So you move like that, then you reach that one, then it is a maximum, so it will curve downwards. So reaching here, this is a minimum. So when it comes like this, then it moves upward. So our curve will be taking that direction. So this will be our curve, which is c of x. This is our curve, which is c of x. So that will basically be our curve, and this curve we majorly are needed to look at the turning points, and you sketch basically indicating the positions and nature of the turning points. So that's why we have concentrated majorly on the turning points. So that will be the sketch. That will be the sketch for our curve. That will be the sketch for our curve. So that is how we shall have our curve. So next we shall look at before we look at that, this shouldn't confuse you. So this one here, it does not mean it is cutting the x-axis at this point. So it shows that it is coming from a point. It is coming from a point that is 200. So this is how our sketch should be looking like. So this shouldn't confuse you, and you say maybe this value is coming from this curve is coming from this given point. So next we are saying the last part is decompose the performance ratio function f of x into partial fractions. So our f of x is this, and when we look at this, this is now a proper fraction, and the denominator has got what we call the linear factors. So like the way we did, we shall try to let this one here be equal to a divided by x minus 1 plus b divided by x plus 4. So multiply through by the LCM, and you should be able to get 6x plus 1 is equal to a into that. As we said, we have different ways how we can do this, but you can easily get a and b by simply setting x to be, for example, -4. So this will be 6 times -4, that is -24 plus 1, which is equal to b into, so this will be to 0, and this is -4 minus 1. So -23 will be equal to -5b. So b will be 23 over 5. Then to get the value of a, you set x to be equal to 1 such that this goes away. So this will be 6 plus 1, which is equal to a into 5. So our a will be 7 divided by 5. So that will be the value of a. Or else you can multiply this through, then you get ax plus 4a plus bx minus this. Combine this and this. Put the coefficients of x in the bracket, a plus b into x, 4a minus b. So equate the coefficients, equate this to 6, equate 1 to this. So we shall be able to get a plus b and 4a minus b. So a is 7 over 5, and B is 23 over 5. We shall get the same answers. So generally, you will be able to have your f of x as 7 over that plus 23 over that. So that will be the f of x decomposed in terms of partial fractions. So in general, the question assesses the candidate's ability to apply differentiation to real-life engineering situations, analyze cubic functions using stationary points, and perform algebraic decomposition of rational functions. So generally, students should demonstrate clear mathematical communication, correct notation, and the appropriate interpretation of results. And that will bring us to the end of our today's video. Please make sure you subscribe, like this video, and share to all your friends. This video can be helpful in one way or the other to your friends. So please make sure you subscribe, like, and be informed that we have a WhatsApp group where we share a lot of such information. You need guides, you need question papers, please join that group. So that is all about Senior 5 Midterm 2 examinations. God bless you all. We meet in our next videos.